Hello, ma'am Green. Nice to meet you. Hi, how are you? I am fine, ma'am, and how are you? I am also fine. How are your studies going on? You fine, ma'am, but I have some doubt in the chapter Refraction and Dispersion of Light in Physics. Ma'am, in this chapter, there are some topics which I didn't understand that are: introduction of the chapter, refraction of light, causes of refraction of light, refractive index and optical density, rules of refraction, refraction of light by a glass slab, and some definitions. And that's it, ma'am. Could you please explain me these topics only? Yeah, sure, but it is too much. So, for your better understanding, we should watch a video on this topic in my computer. Okay, fine, ma'am. Okay, let's go to my computer room. Okay, I am opening the video. You can see and understand it. Okay, ma'am, I am waiting. So let's begin the video. Hello students, I am Miss Green, ma'am. Today I am going to teach you an interesting chapter which is refraction and dispersion of light. So let's begin. In class 7 we learned about some of the basic properties of light. We learned about light normally keeps propagating along a straight path in a given transparent medium. It however gets significantly reflected when it falls on a shining or a polished surface. The phenomenon of reflection of light is governed by the two well-known laws of reflection. It often happens that a light ray propagating in one transparent medium gets to enter and then propagate in another transparent medium. For example, or light ray initially propagating in air, main falls on a glass block on the surface of water in a container. We will now study, in some detail, the characteristics of the phenomenon of the passes of light from one medium to another. Now let's talk about refraction of light. When a ray of light propagating along a straight line in one transparent medium enters another transparent medium, it is observed to usually change its direction of propagation, or to bend its path. This is observed as due to the phenomenon known as refraction of light. Such observations are basically due to a change in the speed of light as it goes from one medium to another. We usually regard refraction as the phenomenon in which a ray of light, propagating obliquely * in one translation medium, changes its direction of propagation or bends its path when it goes a different transparent medium. Is it possible to observe refraction through a setup of the activity? Now let's see the activity on the screen. In this activity, take two coins. Place one coin at the bottom of a beaker and the another alongside the beaker. Now, half fill the beaker with water. Next, observe the two coins by looking vertically downwards from the beaker. What do you observe about the position of the coin in the beaker compared with the coin kept alongside the beaker? The coin in the beaker appears to be raised up with respect to the coin alongside the beaker. Now let's see the second activity. Dip a pencil in a glass of water at about 45 degrees to the surface of the glass. Examine the appearance of the pencil when viewed at an angle to the surface of the glass. What do you observe about the appearance and shape of the pencil? The pencil appears bent near the surface of water. We say obliquely because a ray of light, incident normally on a surface, kept on going straight without bending its path. This basic change that about to occur is the change in the speed of light as it goes from one medium to another. Refraction, basically speaking, implies on this change in the speed of light. We however observe it practically through its prime effect, the bending of a ray of light incident obliquely on the interface between two media. Now I am leaving. The next topic will be explained by Mr. Charlie. Okay students, bye.
Hello students, I am your teacher Mr. Charlie, so the rest of the chapter is going to be explained by me. So let's talk about the cause of refraction of light. The speed of light is different in different media. In vacuum, light propagates at a speed of nearly 3 × 10⁸ 3 kilometers per second. However, where it's inked or any other transparent medium, its speed decreases. It is this change in speed of light that causes a light ray to bend when it goes from one medium to another. Thus the bending of light ray is basically due to a change in the speed of light when it goes from one medium to another. The speed of light in a given medium is taken as an indicator of its optical density. We say that the more is the speed of light in a given medium, the less is its optical density, and vice versa, as a vacuum or free space or air has the least optical density, because the speed of light is maximum in vacuum. Of any, the one having a higher value for the speed of light in it, is referred to as the optical layer of the two media. The other, having a lower value for the speed of light in it, is referred to as the optical density of the two media. Thus, higher optical density, optical denser medium, lower speed of light, lower optical density, optical rare medium high speed of light. You can see the diagram also. After this you see the table on screen where it's showing the representative values of speed of light in some media. The ratio of the speed of light, in a given pair of media, gives us a measure of the extent of refraction for bending of the ray of light as it goes from one of these media to the other. We use this ratio to define a term called the relative refractive index for a given pair of media. Relative refractive index of medium 2 with respect to medium 1. The refractive, or absolute refractive index of a medium, is defined as follows. You can also see the diagram on the screen. Now let's talk about refractive and optical density. It is now easy to realize that the refractive index of a medium is an indicator, as well as a measure of its optical density. The more the refractive index, the more is the optical density. Now let's talk about the rules of refraction. We can easily understand the observations associated with the phenomenon of refraction of light in terms of two rules. We state them as follows. First is the ray of light bends towards the normal when it goes obliquely from a rare medium to an optical density medium. Second is the R of light bends away from the normal when it goes obliquely from an optically denser medium to an optically rarer medium. We use these rules for understanding many phenomena based on the refraction of light. Let us see how we can use these rules to understand the observation made by and the activities. Considered for the case of a pencil partially immersed in water. The ray of light starting from, say, the tip of the pencil, and away from the normal as they move from water, optically denser to optically rarer. To us, therefore these appear to be coming from a point that lies about the actual position of the tip of the pencil. The same is true for all other points of the pencil underwater. The part of the pencil, underwater, thus, appears bent with respect to its part above water. Proceeding in exactly the same way we can understand why a pond appears less deep than it actually is. A coin put in an empty cup, not visible before, becomes visible after some water is poured into the cup. In the two ray diagrams, given on the screen, we see that it is the bending of light rays away from the normal, as they move from an optically denser medium, water to an optically rarer medium air, that is responsible for our observations. Thank you students, I conclude here. Now you will be taught by Ma'am Lisa.
Hi students, I am Lisa. Now I am going to explain you refraction of light by a glass slab. A parallel-faced glass slab can be easily used to study the basic features of the phenomenon of refractions of the room. Let there be just one very narrow pinhole opening through which a fine pencil of light enters the room. Best pencil of light would be visible through the dust particles coming in its way. Now take a rectangular slab of glass and introduce it in the part of this visible pencil of light. We will observe that the path of pencil of light, coming out from the glass slab, gets displaced with respect to its original path. This is because of bending of light as it goes from air to glass and then from glass to air. Note the bending may not be observed if the glass slab is not sufficiently thick. Next activity is draw a long thick straight line on a sheet of white paper using a sketch pen or a marker pen. Place the sheet on a tabletop. Now take a glass slab and place it over the line in such a way that one of its edges make an angle of about 30 degrees with the line. Look at the portion of the line under the glass slab from the opposite edge with respect to the line. What happens now? Next place the glass slab such that it is normal to the line. Does the part of line under the glass slab appears bent now? We draw below the path of a ray of light as it moves through the two opposite parallel sides, A and CD of the rectangular glass slab. We observe that, on refraction through the parallel-faced glass slab AB, the final refracted ray, RS, is parallel to the incident ray PQ, by a amount, d, say. This displacement is known as lateral displacement. The incident ray, PQ, bends its path and moves along the direction of MN with the glass slab. Now I am going to tell some definitions that are. The initial ray PQM falling on the glass slab, is known as the incident ray. The part of the ray MN with the glass slab is known as the reflected ray. The final ray NRS, coming out of the glass slab, is known as the emergent ray. The angle between the incident ray PQM and the normal at the point of incidence M is known as the angle of incidence. The angle between the reflected ray MN and the normal at the point of incidence is known as the angle of refraction. The angle MNT is equal to angle and angle TN are equal to angle ER. Similarly, the angles of incidence and refraction respectively, at the face CD of the glass slab. It turns out angle E is equal to angle A. So the video is ended here. I hope you understand and enjoyed the video. Yes ma'am, after watching the video my all doubts are clear. I enjoyed the video also, thanks a lot ma'am. You're welcome dear. Okay ma'am, now I am going to my home, meet you soon, bye and have a good day. Okay dear, meet you soon and also have a good day.